Hello everyone, welcome to AB Math Solutions channel. In this video, we are going to see about power rule of derivatives. So consider the function f of x is equal to x cube. We know that f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. If f of x is equal to x cube, then f of x plus h is equal to x plus h the whole cube. So substitute instead of f of x plus h and f of x, you will get limit h tends to 0 x plus h the whole cube minus x cube by h, expanded using a plus b the whole cube formula. So x plus h the whole cube expansion is x cube plus 3x square h plus 3xh square plus h cube. So we can cancel plus x cube and minus x cube. So the next term will be, so limit h tends to 0, 3x square h plus 3xh square plus h cube by h. So let's take the common factor out. Here h is common. So the next step is limit h tends to 0, h of 3x square plus 3xh plus h square by h. Cancel h and h. So limit h tends to 0, 3x square plus 3xh plus h square. Now we can apply the limit. When you apply the limit, h tends to 0, 3xh plus x square term will be 0. So your answer will be 3x square. So when f of x is equal to x cube, then f dash of x is equal to 3x square. So we got the derivative for f of x is equal to x cube. So let's consider the points. So when x is equal to minus 1, f of minus 1 will be minus 1 the whole cube. So minus 1 the whole cube, answer is minus 1. So the point is minus 1 comma minus 1. Similarly, when you substitute positive value, for example, when x is equal to 1, f of 1 is equal to 1 cube, which is 1. So the point is 1 comma 1. So like this, we can substitute minus 2 plus 2, minus 3 plus 3 and so on. So the resulting is a curve. So this is the curve for the function f of x is equal to x cube. So this blue line represents the function x cube, and this red line represents the function 3x square. Since 3x square is also a function, we will get a curve. So let's find what is the instantaneous rate of change at a particular point. So let us consider x is equal to 2. So we are going to find what is the instantaneous rate of change at x is equal to 2. So the change in x is 1 and change in y is 12. So the slope is 12 by 1, which is equal to 12. So when f of x is equal to x cube, f dash of x is equal to 3x square. So here, since we found the slope of tangent, it is f dash of x. So f dash of x at x is equal to 2 is f dash of 2 equals 3 into 2 square, which is 3 times 4, and it is 12. So f dash of 2 is equal to 12. So the slope of tangent at x is equal to 2 is 12. So we know when f of x is equal to x, then f dash of x is equal to 1. And when f of x is equal to x square, then f dash of x is equal to 2x. When f of x is equal to x cube, then f dash of x is equal to 3x square. So by observing this, in general, we can frame it as when f of x is equal to x power n, then f dash of x is equal to n times x power n minus 1. So the power rule of derivative is when f of x is equal to x power n, then f dash of x is equal to n into x power n minus 1. So we know how to find the derivative for the function x, x square, x cube and so on. So how about the constant line? How about the line which is parallel to either x-axis or y-axis? Let's take 2 points on the straight line which is parallel to x-axis. So one point is 2, 3 and another point is 5, 3. Since this line is parallel to x-axis, our y value will be same. So when you find the slope, it will be equal to 0. So since the slope of this straight line is which is parallel to x-axis is 0, in general we can say that slope of any line which is parallel to either x-axis or y-axis is 0. So if f of x is equal to c, then f dash of x is equal to 0, where c is a constant term. Either we can say it as f dash of x, or we can say it as d of c by dx is equal to 0. So I hope everyone understand about the power rule of derivative and the derivative of a constant term. Don't forget to subscribe my channel. Thank you.